So, first we'll start with the first theory, which explains about the inner structure of atom and the matter also. So, first theory is the Dalton's atomic theory. First theory is called Dalton's atomic theory. According to Dalton's atomic theory, matter. What is matter? Matter is made up of very small particles called atoms. What is this? Matter is made up of atoms, according to this Dalton's theory. And one more property of this atom. Atoms are indivisible in nature. Atoms are not further divided. Atoms are indivisible in nature. And according to Dalton's atomic theory, next property of atom is atoms neither created nor be destroyed. Atoms of same elements have same properties. Atoms of same elements have same properties, and different elements have different properties. And he explains about the formation of chemical bond. What is that? Atoms combine to form compound. He explains about formation of chemical bonding. So these are important postulates of Dalton's atomic theory. He explains about formation of chemical bond. But why chemical bond is formed, failed to explain. But it is a one major drawback that atoms are indivisible. But according to modern concept, atoms are divisible in nature, and it contains many particles, subatomic particles like electrons, protons, and neutrons. Atoms neither created nor be destroyed, and it is according to what type of concept? It is according to what is that? Law of conservation of mass. Law of conservation of mass, and also this theory according to law of multiple proportions also. Dalton's theory according to law of multiple proportions, and one more drawback is the same elements have same properties and different elements have different properties. Atoms of same elements have same properties. Here, one example, in case of isotopes, what are isotopes of hydrogen? Protium. Next is the deuterium. Third isotope is called as a tritium. In these three isotopes, the atomic number is same and the mass number is different. Generally, physical properties means melting points, boiling points, density. These are called physical properties. Physical properties generally depends on mass number, that is denoted by A. We know that mass number means the number of protons plus the neutrons. And chemical properties like chemical reactions. Chemical properties depends on atomic number. So one more drawback is he explains that atoms of same elements. These are atoms of same elements. They have same properties, but here these elements have different properties. So here physical properties depends on mass number. Chemical properties depends on atomic number. This is also one drawback of Dalton's atomic theory. So first theory which is proposed is Dalton's atomic theory. Next, we'll start with fundamental particles. What are fundamental particles? Or what is that? It is called as a subatomic particles. We'll discuss about the fundamental and or it is also called subatomic particles. Discovery will discuss. First fundamental subatomic particle discovered is electron. So electron discovered by one scientist J. Thompson, and by one experiment that is called as the discharge tube experiment. Discharge tube is also called discharge tube is also called Crookes tube, and this long sealed glass tube. Here it is a long and sealed glass tube. And if you take example, hydrogen in this, hydrogen contains one proton and one electron. So if you take hydrogen, contains one proton and one electron, and we maintain what is that low pressure conditions, low pressure conditions we maintain. It is connected to external vacuum. Then what is that low pressure conditions are maintained? Low pressure means distance between gas molecules increases, and it is connected to two electrodes. One is negative, one is positive. This negative is called cathode, and positive electrode is called as an anode. And we maintain more than 1,000, 10,000 volts of potential difference. Okay. At these conditions, that we maintain low pressure and high voltage. At these conditions, the distance between gas molecules increases, and gas molecules collide with each other, and distance also increases, and because of this, loosely bonded electrons are separated out, and this stream of electrons are called cathode rays. This stream of electrons are called cathode rays. So what are properties of cathode rays? Cathode rays travel in straight lines. So first property, cathode rays travel in straight lines. And what is the nature of this cathode rays? Cathode rays are matter waves. Matter waves, because it is obtained by matter. Matter waves are deflected in electric and field and also magnetic field. Cathode rays can ionize gases, and velocity equals to velocity of light, that is 3 into 10 to the power of 8 meters per second. When cathode rays strikes heavy metals, what type of rays are generated? X-rays are generated. Penetrating power is also more. So these are important properties of cathode rays. After that, what is that? The charge of electron is measured. Charge of electron, here cathode rays are electrons. Charge of electron is measured by one experiment that is called as a Millikan's oil drop method. Millikan's oil drop method. So according to the method, charge of electron is equal to Q is equal to NV. N is equal to number of electrons. Q is equal to charge of electron. So from this, the charge of electron is calculated. That is equal to what is that? Minus 4.8 into 10 to the power of minus 10 electrostatic units. And one more unit is that is minus 1.602 into 10 to the power of minus 19. What is that? This is coulombs. This is the charge of electrons. So charge of electron is measured with the help of what type of Millikan's oil drop experiment method. After this charge of electron, mass of electron also calculated. So mass of electron, how it is calculated by one more experiment by Thompson. Here in this experiment, E by M value calculated. So one side positive electrode, one side negative electrode, and other side what type of positive perforated positive electrode is used. And here zinc sulfide spin is arranged. It is a zinc sulfide fluorescent material. So when what is that here? The gases are present in this ionized high voltage low pressure conditions, and this electron, stream of electrons strikes at this point. Okay, we can take this point as A on this fluorescent material, but if we apply external electric field, this electron, stream of electrons strikes attracted by positive side, deflected by positive, and strikes at point B. Okay, if you apply external magnetic field, this are strikes at the point C. So if we apply same electric field and magnetic field strength, again this rays strikes at point A only. So from this magnetic field strength and electric field strength, E by M value calculated. So what is the charge to mass ratio of electron? That is always equals to E by RB square. E by RB square. What is E? E is called as the electric field strength. R is equal to how much radius it is deflected in electric field or magnetic field strength. V is equal to magnetic field strength. So from this electric and magnetic field strength, the charge to mass ratio of electron measured, and that is equals to minus 1.758 into 10 to the power of 11 coulombs per kilograms. After that, mass of electron is equal to charge by charge to mass ratio. What is the charge of electron? 1.602 into 10 to the power of minus 19 coulombs by minus 1.758 into 10 to the power of 11 coulombs per kilograms. From this, we get the mass of electron, that is 9.1 into 10 to the power of minus 31 kilograms. So we get the mass of electron. This is mass of electron, 9.1 into 10 to the power of minus 31 kilograms. At the same time, that is, we can find out in EMU value also, AMU value, atomic mass unit, that is 0.000548 atomic mass units. What is that? Mass of electron. And what is 1 atomic mass unit? That is equal to 1.66 into minus 24 grams. This is also called avogram. So this is the E by M value of electron, and this is the mass of electron in different units. And next is E by M value of electron does not depend on what type of gas is used in that discharge tube experiment, but in case of protons, E by M value depends on the nature of gas. In case of only hydrogen, E by M value is maximum in case of protons. After that, protons also discovered by Goldstein by same experiment, that is called as a discharge tube experiment. And in this experiment, what type of electrode is used? Perforated cathode is used. This is the anode rays. Okay, anode rays are discovered by Goldstein. Who is that? Scientist is Goldstein. Anode rays are discovered, and this is also called as a canal rays experiment. Why it is called canal rays experiment? In this case, we use a perforated cathode which contains very small pores, and here one fluorescent material is used, that is the zinc sulfide stream. And when we use a low pressure and high voltage conditions, from atom electrons are separated and it is attracted towards one side, and this positive nucleus which is attracted towards the opposite side. This nucleus again contains both the protons and the neutrons. So EVM value does not depends on EVM value depends on nature of gas. Okay, so here this all that are attracted towards this perforated cathode and strikes on zinc sulfide stream, it gives some scintillation. So these are called anode rays. Again, anode rays also what are properties here? Travel in straight lines. Anode rays travel in straight lines. Again, these are matter waves. What is the nature of matter waves? Again, it is deflected in magnetic field and electric field externally. Anode rays and anode rays velocity velocity 1 by 10th of velocity of light, because these are more massive particles. So anode velocity is 1 by 10 compared to velocity of light, and compared to cathode rays, penetrating power is less, and it is also, this rays also ionize gases. And one more property, E by M value depends on E by M value depends on nature of a gas, nature of gas used in that discharge tube. And if it is hydrogen gas, then what is E by M value? In case of hydrogen gas, that is maximum. That is equal to 9.5 into 10 to the power of 4 coulombs per kilogram. In case of hydrogen, the value is more. So these are properties of anode rays. Anode rays are nothing but stream of protons, which are ionized from atoms, that is gaseous atoms. And next is what are the charge of this proton? What is charge of this proton? First, we start with the charge is equal to plus 1.602 into 10 to the power of minus 19 coulombs. Charge of proton. And we use one more unit, plus 4.8 into 10 to the power of minus 10 electrostatic units. And what is the mass of this proton? 1.673 into 10 to the power of minus 24 grams, or 1.007 atomic mass units. This is charge and mass of a proton. And this proton's mass is 1837 times. Okay, 1837 electrons equals to mass of one proton. So more massive particles compared to electrons. After that, next neutrons are discovered by nuclear transmutation reaction. Neutrons discovered by James Chadwick. Okay, what is the nature of these neutrons? How these are discovered? When beryllium nucleus. What is beryllium? Beryllium contains mass number, atomic number 4, mass number 9. So it contains, beryllium contains 5 neutrons, 4 protons plus 5 neutrons. Beryllium is when bombarded with alpha radiation. What is alpha radiation? That is nothing but nucleus of helium. So nucleus of helium is, it contains 2 protons and 2 neutrons, alpha radiations. What is helium? When we remove these electrons from helium, we get alpha radiation. That is also called nucleus of helium. So when this ray strikes this, bombarded with this beryllium nucleus, what is that? This is a helium. What is the, here 2 protons are added here. So 6 protons are formed, and 1 neutron is added here. We get 6 neutrons, and here carbon is generated and 1 neutron is separated. That is atomic. Here mass number we can take it as units. So neutrons are discovered by this method. When beryllium is bombarded with alpha radiations, then what happened here? In this case, beryllium is converted into carbon, and from this, neutrons are separated out. What is the nature of this neutron? Neutron is a neutral particle. This is a neutral particle. And what is E by M value of neutron? We cannot find out because there is no charge. So here we write charge is equal to 0. Mass is equal to 1.675 into 10 to the power of minus 24 grams. It is slightly higher than mass of proton, or 1.008 atomic mass units. So here in this way, neutrons are discovered, electrons are discovered, protons are also discovered. Some other particles also present in nucleus. What are the particles present in nucleus? That are mesons, neutrinos, antineutrinos, different types of particles present in nucleus. And next, after that, discovery of these fundamental particles, atomic models are proposed. Atomic model, first atomic model, which explains arrangement of these fundamental particles in an atom. First atomic model proposed by J. J. Thomson. J. J. Thomson, and this atomic model, it is also called as a watermelon model. Watermelon model, or it is also called as a plum pudding model. Plum pudding model, or it is also called as a raisin pudding model. So, what is the Dalton's atomic theory? What it explains about this? So, Thomson's atomic model. J. J. Thomson's atomic model. This is called. So, according to this J. J. Thomson's atomic model, what is the nature of atom? Atom is spherical in nature, and in that spherical, positive charge is uniformly arranged. This is totally positive charge, and negatively charged electrons are arranged with less or more uniformly. This is called what is the Thomson's atomic model. What it explains? It explains about one important point that is called electrical neutrality. It explains about electrical neutrality of atom according to J. J. Thomson model, but failed to explain what is that the stability of atom. Stability of atom is not explained by Thomson, but it explains about electrical neutrality of an atom. And next is, after that, next model is Rutherford's atomic model, or it is called alpha rays gold foil experiment. In this experiment, very thin gold or silver foils are used. Very thin gold or silver foil. Why gold or silver is used? Because gold or silver is more malleable in nature. Example, in case of gold, what is the mass number also more? More positive charge is present in nucleus, that is 79 protons. And when observe that, what are observations here? Observations of Rutherford atomic model. According to his observations, he observed that many alpha rays, he passed alpha rays through this gold foil, very thin gold foil, because when compared to all metals, gold is more malleable in nature. So he observed that many alpha rays passes through gold foil without any deflection, but very few few radiations are deflected. Okay, and if you take example, in 20,000 radiations, one radiation shows a complete deflection. So, according to this, he explains that from these observations, he explains that atom contains large empty space. Large empty space. Atom contains large empty space. And next, we observe that what is that? Electrons revolving around nucleus in orbits, like planets revolving around sun. So it is called as a planetary model of an atom. This is also called planetary model of an atom. And size of atom is 1 lakh times greater than size of nucleus. Size of nucleus according to this Rutherford's atomic model. When electrons are revolving around nucleus, these electrons are balanced because of centrifugal and centripetal forces which are equal and opposite. What is this centrifugal and centripetal forces? Here, electron is attracted by nucleus because electron is negative, nucleus is positive. That is called electrostatic forces or Coulombic forces. And because of this massive electron, high velocity, Outside also some opposite attractive forces present. So these both forces are equal and opposite, so atom is stable. So here, what is that when electron revolving around this, what is that here, kinetic energy of electron, we can write it as a half mv square is always equals to 1 by 4 pi epsilon naught. Epsilon is the permittivity of medium into this atomic number, that is Z into Z by distance between this nucleus to electron, that is indicated by this way. So both forces are equal and opposite. That is atomic number is equal to electron charge, and 1 by 4 pi epsilon naught, that value is equal to 9 into 10 to the power of 9 Newton meter square per coulomb square. This is the value of 1 by 4 pi epsilon naught. So from this, what is that? According to Rutherford model, electron revolving around nucleus. In this, there are both forces are there, centrifugal and centripetal forces. Because of massive particle, it contains some kinetic energy. Inside, electrostatic forces or coulombic forces are present. Both are equal and opposite. So electron is stable. So this value is equal to 9 into 10 to the power of 9 Newton meter square per coulomb square. This is the Rutherford's atomic model. But what is the drawback of this model? Main drawback of this Rutherford's atomic model. First, it is against to modern concepts of physics. So what is this? According to this modern concept, when electron, charged particle like electron, revolving around nucleus, it should lose its energy continuously, and that electron should fall in nucleus by 10 to the power of minus 18 seconds only. And in this process, energy evolved is continuous, and this continuous energy, when recorded on photographic plate, the spectrum should be continuous. So what type of spectrum should obtain? That should be continuous in nature, but actual spectrum obtained is discontinuous. This is the first drawback. And second drawback is, what is the second drawback? Failed to explain about electronic structure of an atom. First drawback, second, electronic structure of an atom. What is this electronic structure? It explains about arrangement of electrons in different orbits, that is not explained by Rutherford's atomic model. So this is the drawbacks of this Rutherford's atomic model, but first time concept of nucleus explained by Rutherford. And next concept is atomic number. So atomic number explained by Mosley, by one experiment, by X-phase. What is that? This is the frequency of X-phase. Root nu is equal to A into Z minus B. From this equation, this is based on this one experiment when X-phase of different atoms have different frequencies. From this atomic number discovered, and Z is called atomic number, and A and B are called as a constants. So what is meaning of atomic number? Atomic number denoted by Z. Atomic number is equal to number of protons or number of electrons in an atom. In case of ions, atomic number is nothing but it is equal to number of protons always. And what is mass number? Number of protons plus neutrons, that is called mass number. This mass number, this protons and neutrons also called as the nucleons, which are present in nucleus. So any element like sodium, atomic number is always right to bottom side, and mass number always right to upper side. In case of sodium, mass number 23, atomic number 11. Sodium contains 11 protons and 11 electrons. And how to find out neutrons? We use the formula A minus Z. 23 minus 11, that is equal to 12 neutrons are present in sodium. 12 neutrons are present here. How to find out atomic number of one element in a group? Use the magic numbers 2, 8, 8, 18, 18, 32. These are called magic numbers. We take an example. Our first group element hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen atomic number 1. So 1 plus 2 is equal to 3 in case of lithium. 3 plus 8 is equal to 11 in case of sodium. 11 plus 8 is equal to 19 plus 18 is equal to 37 plus 18 is equal to 55 plus 32 is equal to 87. This is the method to write atomic numbers of elements. And after that, we use magic numbers here. After that, we'll discuss about what is that isotopes. Isotopes are atoms of same elements with the same atomic and different mass number. Example, chlorine isotopes, chlorine with 37 mass number. And what is 17 atomic number? Chlorine with 35 mass number with 17 atomic number. Every natural element always contains isotopes, but synthetic element contains no isotopes. So here in nature, how much amount is present? It is 25% and it is 75% present in nature with 35 mass number. So from this, we can find out average isotopic mass. Isotopic mass that is equal to 35, which is present with 75%, 37, which is present with 25% by total 100. What is the value we get? 35.5. This is called as a mass number. So in this way, average isotopic mass is calculated. Isotopes contains, once again, same chemical properties, but physical properties are different. In case of isotopes, the next is isotopes. What is isotopes? Same number of neutrons. Any two elements contain same number of neutrons that are called isotopes. So different here, physical properties are different physical properties and the chemical properties also different in case of isotopes. One example for isotopes is sodium and magnesium. We take example. Sodium 23 atomic mass number, 11 atomic number. Magnesium 24 with 12. And how many neutrons are present in this case? 12 and 12. But both contains different atomic and mass number. So physical properties and also chemical properties are different. Next is isodiaphers. Isodiaphers. If two elements contains A minus 2Z value, same. A is the mass number, Z is atomic number. If two elements contains A minus 2Z value is same, these are called isodiaphers. Again, isodiaphers have different physical and chemical properties. We take example, fluorine and sodium. This is example for isodiaphers. Next is isosters. What is nature of this isosters? Same atomicity. They contain same atomicity. At the same time, same number of electrons. That type of molecules are called as a isosters. We take example for isosters, CO2, N2O. So in CO2, how many atoms are present? 3 atoms are present. N2 also, how many atoms are present? 3 atoms are present. And in CO2, total number of electrons, carbon contains 6, oxygen 8 plus 8. So what is that? 22 electrons are present. In this case, nitrogen 7 plus 7 plus 8. That is equal to again 22 electrons are present. These are called as a isosters. And next is the isoelectronic ions. Isoelectronic ions. If different ions contain same number of electrons, that are called isoelectronic ions. We take an example, F minus 1, O minus 2 here. Chlorine atomic number 9 plus 1. Minus 1 means plus 1. The total is equal to 10. Oxygen atomic number is 8. Plus 2 we get a 10. Nitrogen atomic number 7. 7 plus 3 is equal to 10. Sodium is plus 1. 10 here. Total electrons 10. Magnesium plus 2. Total electrons 10. Aluminium plus 3. Total number of electrons 10. So all these isoelectronic ions contain same number of electrons. Electrons number is same. And what is the size of this ion? Generally, anion size is greater than neutral atom. Neutral atom in case of isoelectronic ions, it is greater than cation. That is a positive ion. Because when electrons increases, then what happened here? Electrons increases, size increases, electrons decreases, nuclear charge increases, so size always decreases. So these are the what is the different types of concepts in this atomic structure. After that, next we'll discuss about nature of light. So light shows both the particle nature and also wave nature. Particle nature explained by Newton, that is called as a corpuscular theory. That theory is called corpuscular theory, which explains about particle nature of light, which are called photons. And next is one more theory that is called as a wave theory. So what is the wave theory? According to this, light is propagated in the form of waves. This is proposed by Huygens. According to this theory, light is propagated in the form of wave nature. This is called as a crust. It is called as a trough. And the distance between two adjacent crusts or trough is called as a, what is it, lambda. This is called as a wavelength. Units are angstrom units, nanometers, picometers. In case of wavelength, 1 angstrom unit is 10 to the power of minus 10 meters, nanometer 10 to the power of minus 10 meters, picometer 10 to the power of minus 12 meters. So this is the wavelength. And next is the frequency. How many waves can travel through a particular distance in 1 second time? That is called frequency. That is units or cycles per second, or what is that? It is also called hertz. And next is the wave number. Reciprocal of wavelength is called as a wave number. And amplitude. This is the amplitude. Height of this crust or depth of this trough is called as a amplitude. Okay. Now we'll discuss about electromagnetic wave theory. Electromagnetic wave theory. According to this theory, this radiations, electromagnetic waves are generated by any vibrating charged particle placed in magnetic field or vibrating magnet placed in electric field. Electromagnetic radiations are generated, and this according to this electromagnetic wave theory, this electromagnetic radiations contains both what is that electric field and magnetic field. This electric and magnetic field both are perpendicular to each other, and they can travel through vacuum also. No medium is required for their propagation. But in a vacuum, all that electromagnetic radiations velocity is same, that is 3 into 10 to the power of 8 meters per second. So this electromagnetic radiations are arranged. What is that? Electromagnetic radiations are arranged. Radiations are arranged with a decreasing of frequency or increasing of wavelength. That is called as a electromagnetic spectrum. So what type of rays with a high frequency and low wavelength is present? Cosmic rays, next gamma rays also there, next X rays also there, next UV rays also there. Next is visible, that is VCR, infrared, and microwaves and radio waves also present in this electromagnetic spectrum. And this cosmic rays to radio waves, wavelength increases, and in case of cosmic rays, frequency is more. So if frequency is more, energy also more. This is called as a electromagnetic spectrum. After that, next is the what is the for to understand the Bose theory. Next important concept is black body radiations. So this black body radiations explained by Planck's quantum theory. What is this Planck's quantum theory? According to Planck's quantum theory, electromagnetic radiation. Okay, when any black body is heated from that black body, because here black body is the perfect emitter and perfect absorber of energy, from black body radiations are emitted. So how these radiations are emitted? These radiations are not continuous, but these radiations are emitted discontinuously. It explains about what is that? The atom contains discrete energy levels or orbits. It is explained by Planck's quantum theory. So, sorry, it explained, yes, Planck's quantum theory, and every radiation contains some discrete or what is a quantized energy, fixed energy that is directly proportional to frequency, or we can write E is equal to NH nu. Nu is the frequency and H is called Planck's constant, 6.625 into 10 to the power of minus 34 joule second. This is the Planck's constant value. It is called what is that black body radiations. So this after this, the next is photoelectric effect. What is the nature of light explained by one more concept, photoelectric effect. If you take example, alkali metal surface, that is 1A group elements, it is alkali metal surface. So when alkali metal surface is struck by these light particles which are called as the photons, from alkali metal, electrons are emitted. All electrons are separated from alkali metals, that is 1A group elements. 1A group elements contains only one electron in outermost orbit. This effect is called as a what is that photoelectric effect. Here photons are called as a light particles, and it contains the energy that is equal to h nu. Some quanta of energy is present and it strikes this to eject electron. Some minimum energy is required, that is h nu naught, and remaining energy is converted into kinetic energy, that is equal to half mv square. So this Planck's quantum theory, photoelectric effect, explains about particle nature of electrons. So according to photoelectric effect, h nu is equal to h nu naught plus half mv square. So what is this? This is called as a work function. This is called threshold energy, and it is equal to kinetic energy of ejected electrons. So this Planck's quantum theory and the photoelectric effect explains about particle nature. And again, Bose theory again depends on this spectra also. Spectra is arrangement of different lines on photographic plate with a decreasing order of frequency or increasing order of wavelength. To record spectra of atom or molecule, we use an instrument that is called as a spectroscopy. Spectra again divided into two types. One is called as a continuous spectra. Second is called as a discontinuous spectra. Continuous and also discontinuous spectra. Continuous spectra, one example is rainbow is one example for continuous spectra. Or when white light is passed through Nicol prism, it is dispersed into 7 colors. White color is white light is passed through prism. What is the role of prism? It disperses the radiations into different wavelength, and these are arranged with a decreasing order of frequency or increasing order of wavelength, and these are arranged without any gaps. Like white light is arranged without any gaps after dispersion. It is called continuous spectra. This continuous spectra again divided into two types. One is called as the emission spectra. Second is called as the absorption spectra. Emission spectra again divided into two types. So that is line spectra, band spectra. It is also example divided into line spectra and band spectra. First, we start with what is important is atomic spectra. When we take an example, this is an atom. It contains one electron. Some energy is given to this atom. Electron is excited. For excitation, it absorbs some energy. Electron absorbs some energy. Remaining energy, which is unabsorbed energy, recorded on photographic plate. What type of spectrum we get? Absorption spectrum. So absorption spectrum contains the dark lines on white background. Dark lines indicates that energy absorbed by electron. That is called missing colors, missing radiations. And excited electron is again de-excited. Because of de-excitation of electrons, we get one more spectra. That is called emission spectra. Emission spectra contains bright lines on dark background of photographic plate. Why we get the bright lines? Because after de-excitation of electron, energy is evolved that is recorded on photographic plate. This is called as a emission and absorption spectra. So this emission and absorption spectra also called as a what is that fingerprints of atoms. This is called as a fingerprints of atoms. So because this is used to detect atoms, so we can call it as the fingerprints of atoms. After that, based on the spectra, Bohr proposed this theory that is called what is that Bohr's atomic model. So according to Bohr's atomic model, atom contains a very small nucleus situated at center and electrons revolving around nucleus in circular orbits. These orbits are denoted by K element or 1, 2, 3, 4. And he explains that number of electrons in an orbit is equal to 2n square. And when K to N shell distance increases, energy and radius also increases, energy and radius of N shell greater than M shell greater than L shell greater than K shell. And when electron revolving around nucleus, its angular momentum is quantized. That is, MVR should be equals to NH by 2 pi. Okay, and these orbits are called as a what type of orbits? Stationary orbits, or these are called stable orbits, or these are called quantized energy levels. What is that stationary or stable orbits? Because as long as energy revolves in this orbit, it does not lose or gain energy. So these are called stationary or stable orbits or quantized because each orbit contains some fixed energy. So these are called quantized energy levels. And radius also calculated by Bose theory. Radius of orbit is equal to, we use the N square, H square by 4 pi square M Z square. So this is the Z is atomic number, E is equal to charge and M is equal to mass of electron. N is orbit number. From this the values if we substituted, we get 0.529 angstrom units. So that is again N square by Z. So this is a formula to find out the radius of orbit. N is orbit number, Z is atomic number, and it is applicable to hydrogen-like species. Energy also calculated by Bose theory. Potential energy plus kinetic energy of electron energy is equal to what is this kinetic potential energy? That is Z square by R. Kinetic energy is equal to that is indicated by plus half mv square. This total energy always from this equal to minus Z square by 2R. So here kinetic generally potential energy is 2 times of kinetic energy. Potential energy always indicated by negative sign only. So from this we get energy is equal to 2 pi square what is that? M z square e to the power of 4 by n square and h square. If you use this value, we get minus 13.6 into z square by n square in electron volts per atom. One unit, one method to find out energy of electron. One more is minus 2.18 into 10 to the power of minus 18 joules into z square by n square. Or one more unit is minus 1312 kilojoules per mole into z square by n square. These are the different methods to find out energy of electron. And he explains about hydrogen spectrum also. What is hydrogen spectrum? Hydrogen spectrum, when electron of hydrogen is de-excited, we get different spectral lines, and this is example for atomic and emission spectrum. When any electron is de-excited to ground state from any higher energy level, we know that what type of spectrum is, what type of lines are obtained. That is called Lyman series of lines. Any higher to first level, what is that? We get a Lyman series of radiations which are in UV radiation, UV region. Any higher to second orbit, we get a Balmer series of radiations which are in visible. Any higher to third level, we get a bracket series of radiations. Any higher to fourth level, what is that? We get a one series of radiations. Any higher to fifth level, sorry, this is the Paschen series of radiations, and these are the bracket series of radiations. These are one series of radiations, and any higher to sixth level, we get a Humphrey series of radiations. This all are in infrared region. This is called as a hydrogen spectrum. So how to find out the wave number of a hydrogen spectrum? Nu bar is equal to 1 by lambda is equal to r z square into 1 by n1 square minus 1 by n2 square. R is called as a Rydberg constant. The value is 10967 per centimeter. Z is equal to atomic number. N1 is ground state, N2 is equal to higher state. Example, in case of Lyman series, okay, N1 is equal to always 1, N2 should be any higher value like this, any higher value. And this first value, if electron jump from second to first, what type of these lines are called as a, these lines are called alpha, or we can call it as a first line also we can call. If electron jump from any third to first level, this is called beta line, and it is also called second line, and fourth to first, it is called third line, or it is a gamma line. So that, so if electron jump from infinite distance, n2 value is equal to, we can take it as a 0. So this is the way we find out what is that alpha, beta, gamma, what is the first, second, third line wave number also we can calculate it. And after that, from this Bose theory, we can calculate velocity of electron also. Velocity of electron is equal to 3.18 into 10 to the power of 6 atomic number by orbit number per centimeter per meters per second, and we use this formula to find out the velocity of electron. So 2.1, or we can take the 2 or 3.1 also we can take. And from this is the Bose theory. After this Bose theory, what are the drawbacks of Bose theory? It failed to explain about Zeeman effect, and also failed to explain about Stark effect. What is the Zeeman and Stark effect? When we use a what is a spectroscope, when we use a discharge tube, when these radiations are recorded on photographic plate, we get spectral lines which indicates the orbits. But if you use external magnetic field or we use external electric field, we observe that splitting of spectral lines. So splitting of spectral lines on what is that is spectroscopy, spectroscope in presence of electric field is called Stark effect and magnetic field is called Zeeman effect. And next is Bose theory is against to modern concept. According to modern concept, subatomic particle like electron shows both wave nature and particle nature, but according to Bohr's theory, electron is considered as a wave particle only. So this is a major drawback of Bohr's theory. And how to find out number of spectral lines also, we use a formula of spectral lines, number of spectral lines, how to find out n2 minus n1 and n2 minus n1 plus 1 by 2. N2 is a higher line, N1 is a lower line. By using of this, we can find out the number of spectral lines on the Bohr's theory of hydrogen spectrum. So after this Bohr's theory, next theory is the de Brolys theory. So Bohr's theory is against to de Brolys dual nature. What is this de Broglie theory? Electron shows what it explains. Electron shows both the wave and particle nature according to de Broglie theory. That is indicated by lambda is equal to h by mv. Lambda is called wavelength and m is equal to mass of electron. Here wavelength is inversely proportional to mass of electron. Means when mass of any particle increases, wavelength always decreases. So we can find out wave nature clearly in case of electrons. And according to this de Broglie's concept, electron shows electron revolve around nucleus with wave nature. So this is the wave nature. And according to this, 2 pi r should be always equal to n lambda. That is called the continuous wave. 2 pi r is equal to circumference of orbit, n is equal to orbit number, L is equal to wavelength of that electron. This is called as a de Broglie's dual nature of matter, and we can use this formula also. Lambda is equal to h by root 2em. Here, what is this? E is equal to potential energy of kinetic energy of electron. M is equal to mass of electron. Or we use this formula, lambda is equal to h by root 2EVM. EV is equal to charge of E is the charge of electron, V is equal to potential difference, M is equal to mass of electron. So for electron, generally lambda value should be equal to 12.27 by root V in angstrom units. This is for electron. What is for proton? Lambda value for proton, that is equal to 0.286 by root V in angstrom units. These are the what is the wavelength values in case of electron and proton. So what is meaning of wave in phase? 2 pi r should be always equals to n lambda, that is called wave in phase. After that, next concept is Heisenberg's uncertainty principle. One more drawback of this Bose theory. According to Heisenberg's uncertainty principle, what is this? Delta x, the mathematical derivation, delta x into delta p greater than or equal to h by 4 pi. Or we write here delta x into p is the momentum, m delta p greater than or equal to h by 4 pi. What it explains, it is not possible to find out exact position and also momentum of electron at the same time or simultaneously. It is called as a Heisenberg's uncertainty principle. So this Bose theory is against to Heisenberg's principle and also what is that De Broglie's dual nature of matter. Bose theory considered electron is particle, but this modern concept considered electron shows both wave nature and also particle nature. And next class, what is it? We'll discuss about what is it? Next concept of electron application parts also we'll discuss in tomorrow's class.